Welcome to the third part of the ValleyFrame USB tutorial about receiver tests in expert mode. The first thing to do is to click on Configure DUT. For this tutorial we will use the same DUT configuration that we used in the previous part, device with specification version 3.1 and Type-C connector. We ran the calibrations for the 10 gigabit per second data rate only, so we will uncheck the 5 gigabit per second data rate and enable the expert mode. We click on Parameters. In the Common tab, we can configure the power automation options. If you remember tutorial part 1 about the station configuration, we selected a power switch to automate the DUT power cycling, which requires N5990A option 008 remote power management support. Since we are testing a bus-powered device, the power will be supplied at VBus. If we tested a device that requires an external power supply, we would have to select main power. We can select which power switch channel to use. The available options depend on model selected. Then we have to enter the power off-on duration, the settling time and the power cycle maximum retries. The off-on duration has to be long enough to make sure that the DUT is completely powered off and the power circuitry fully discharged. The settling time is the time ValleyFrame will wait after the DUT is powered on to proceed with the error rate test. And the maximum number of power cycle retries will limit how many times ValleyFrame will retry to train the DUT should the link training fail. We selected the USB IF fixtures, which were calibrated earlier, and the Jaybird error detector to perform the error rate test. We select the Jaybird generator channel that we calibrated and an error detector channel out of the channels that are present in license on the instrument. We go now to the receiver 10 gigabit per second tab to configure the loopback training and the error detector. Several link training methods are supported, depending on the DUT type and the hardware. For this tutorial, we are using a device, so we will select warm reset. If the DUT was a host, we would select power on reset. If we were a silicon vendor and want to test our PHY without a USB LT SSM, we can test it without a proper link training by selecting vendor specific. We can select how the electrical idle for LFPS signals is generated out of several options. A static zero signal, a half-rate clock signal, and the M8020A idle or squelch feature. This is the script containing the block definitions and sequence that will be used to train the device into loopback mode, which was generated using the BitifEye USB link training suite. In case you need to debug the link training of your DUT or need a special link training sequence, the BitifEye USB link training suite is the perfect tool to create a custom script that you can export and use in ValleyFrame. To do so, just click on Browse and select your script. We can configure the differential voltage levels for the link training, the calibrated level for long channel RX tests, or different custom levels for long and short channel tests. Finally, here at the bottom we have parameters to configure the error detector, like the CDR loop bandwidth, transition density, and peaking, the error detector receiver equalization preset, sensitivity, and auto-align timeout. The equalization presets available depend on the factory calibration of the Jaybird M8020A. The sensitivity level can be either normal or high. We are now done with the configuration, so we close this dialog by clicking OK, and once more OK. The procedure tree is built. The calibrations are displayed in green, which means that they are already run. Since we will be focusing on the receiver tests, we will collapse the calibration and transmitter sections. The compliance test is the receiver tolerance test, as it is described in the compliance test specification. As you know, predefined sinusoidal jitter amplitudes at certain frequencies are tested for 2 minutes each. If you are testing your DUT for compliance, the long channel and short channel compliance tests are the only ones required. However, in expert mode we offer additional tests like the following. The constant parameter stress test gives us total flexibility to configure every single impairment as we want. The jitter tolerance test is similar to the compliance test, but instead of testing fixed sinusoidal jitter amplitudes, the jitter amplitude is increased beyond the compliance level to find the point of failure and how much jitter tolerance margin the DUT has. This test gives a great insight about your DUT. Your DUT may pass the compliance test, but that is not enough. You will want to make sure that it has a good jitter tolerance margin to guarantee the best performance in normal operation. Finally, the sensitivity test consists of measuring the error rate while decreasing the eye height or differential voltage beyond the minimum defined by the specification to determine the minimum error-free level. The receiver tests are performed at both Type-C lanes with a long channel and a short channel. All these receiver tests are required for a complete characterization, but for this tutorial we will run the long channel and short channel test at lane 1 only. Again, we will move the valley frame window and increase the size of the log view for a better data display. Please click on Start. We get a reminder to make sure that lane 1 is connected to the test equipment. A connection diagram shows how to connect the instruments and fixtures to the DUT. Something very important for Type-C testing: do not forget the jumper in the right position on the device or the host fixture 1C. When everything is done, press OK. We have to make sure that the right polarity is applied to the DUT, otherwise it can be damaged. Usually valley frame is asking us here to disconnect or power cycle the DUT, but not here. Thanks to N5990A option 008 remote power management support, the software is taking this when needed. Awesome! For the short channel receiver tests we need another fixture, so we make the connections shown in this diagram, making sure that the jumper is on the right position. When everything is connected, we click OK. And that's it! The receiver tests are complete. We can save the test results together with the calibration data by going to File and then save the results as workbook. That's it! Thank you for watching.